Good morning. How are you? Hope you are all in the pink of health. I am fine, and you are watching bond making and bond breaking channel. Hope you visit my first part of this lesson. Now we have discussed about the IUPAC nomenclature on this chapter. So write IUPAC IUPAC nomenclature. So this is IUPAC nomenclature. Okay. Write the first problem. CH3, CH2, CH2, Cl. Okay? CH3, CH2, CH2, Cl. Okay. This is number of chlorine 1, and this is alkane group, mono haloalkane. This is halo group, so mono haloalkane. So numbering 1, 2, 3. According to the number of carbon, this is 1, 2, 3, that is pro, and the bond between them is single. The bond between them is single. Therefore, this is 1, 2, 3. 1 chloro, 1, 2, 3. Number of carbon 3. 3 means pro. That and the bond between them single, that is N. So this is 1 chloro. Now 1 chloro. Okay. Now the second problem is CH3, CH, Br, CH3. Let's see if the valency of carbon has fulfilled it. Carbon 3, 4. Okay. Carbon 1, 2, 3, 4. Fine. Carbon 1 and 3, 4. Now think the name of this compound. 1, 2, 3. The position of the bromine is 2. The position of the bromine is 2. So this is 2 bromo. 2 bromo. Okay. Because the position of the bromo is 2. 2 bromo. And this is the number of carbon, and the number of carbon is 3. Therefore, we call pro, and the bond between them single. So this is propane. Okay, this is chloro, and the number of carbon 3 means pro. 1 chloro, pro, bond between them single, N, 1 chloro propane. And the next one is the position of the bromine 2. The position of the bromine 2. Therefore 2 bromo, and the number of carbon 3 means pro, and bond between them single, N. So 2 bromo propane. Third one is CH3, C, CH3, CH3. The hand of the center carbon, one hand contain methyl group, another also, and the rest hand have one iodine group. Okay, so this is 3 degree. The bulky group of this the number of the bulky group 1, the number of the bulky group 2, and the number of bulky group 1, 2, 3. So this is 1° haloalkane. This is 2° haloalkane, and this is 3° haloalkane. Okay, it depends on the bulky group. The number of bulky group is 1, the number of bulky group is 2, the number of bulky group is 3. So this is 1° haloalkane, this is 2° haloalkane, and this is 3° haloalkane. We may call it tert. And 1, 2, 3, 4. 4 means butyl. So tert butyl iodine. Okay. If we numbering it, we get 2 iodo 2 methyl. 2 iodo, number of position of iodine is 2, number of position of this methyl group is also 2. Therefore, we may write 2 iodo 2 methyl. 2 iodo 2 methyl 1, 2, 3. 3 means propane. Okay. 2 iodo 2 methyl 1, 2, 3. 3 means pro, and bond between them single. Therefore, this is N group, and we get the name of this compound 2 iodo 2 methyl propane. Very fine, very easy. Now take more examples. Now we go into the arenes group. Okay, this is benzene when hide. The carbon of this group we may write in this way 1, 2, 3. The carbon 1 hand, 2 hand, 3 hand. The valence of the carbon is 4, and the hand 1, 2, 3, and one hand must have with the hydrogen. If we replace this hydrogen with the substitution reaction, we may get any halo group, that is chlorine. So write the name of this compound. The name of this compound is, this is chloro and this is benzene. Therefore, we may write chlorobenzene. So we write chlorobenzene. Chlorobenzene. Okay. Okay. Next. The name of this compound. Okay. This is benzene, and this position is called ortho position. This position is called meta position. This position is para position. This is meta position, and this is also ortho position. Okay. Now write the name of this compound. Let's see. We may call meta because the position of this bromine is meta. So meta, number of bromine 2. Therefore, this is di. And this group, the name of this element is bromine, and we call them bromo. If the chlorine, we call them chloro. So this is bromo. Meta dibromo. Meta dibromo. Very good. Or we can write in this way: 1, 2, 3, 4, 5, 6. Okay, we can write in this way: one position bromine, and the position of this bromine is 3. So we can call them 1, 3 dibromo and this is benzene. So 1, 3 dibromo benzene. Okay, very easy. Now if we take this compound, write the name of this compound. This is benzene, this is bromine, and this is bromine and bromine. Find out the name of this compound. Think about it. This is a symmetrical position. Okay, so we can write it sim. This is symmetrical sim tribromo, because the number of bromine equal to 3. So this is tribromo. Okay, tribromo benzene. We should write the name. In a single line. Okay, but the size of this board is very small, so I write in this way, but you must write in a single way. This is chlorobenzene. This is 1,2-dibromobenzene or meta-dibromobenzene, and we can write in this way: 1, 2, 3, 4, 5, 6. So we can write 1, 3, 5, 1, 3, 5 tribromo benzene. Okay. We take more examples. CH3, CH3, then CH2. Write the name of this compound. The halogen group, the number of chlorine equal to 1. If we take this position 1, 2, 3, we get 1 chloro. This is chlorine. 1 chloro. So 1 chloro. This is a methyl group. This is also a methyl group. So we can call the number of this methyl is 2. The number of this methyl is 2. The position of this methyl 2. The position of this methyl 2. So 1 chloro, because the position of this chlorine is 1. So this is 1 chloro, 2 because the position of the both methyl group is 2. So 2 dimethyl. This is the number of methyl 2. So we call dimethyl. So 2 dimethyl. 2 dimethyl. 2 dimethyl. Okay. I repeat it again. You write the IUPAC name in a single line. Okay. 1 chloro, 2 dimethyl, 1, 2, 3 pro N. Okay. I hope you understand it. And the next problem is. CH3 CH2 1 2 3 4 1 2 3 4. Write the number, write the IUPAC name, write the name. If the chlorine or halo group is attached to the different carbon, we call them weak. Okay, so this group is vicinal, or from there we can write weak. If the halogen is standing the two different carbon, we call them weak. So this is weak. Okay, this is dichloride. So weak dichloride. Weak dichloride. Or simply we may call 1 2 3. So 1 2 dichloro chlorine. The position of this chlorine is 1, the position of the chlorine is 2. So 1 2 dichloro, 1 2 dichloro. The number of carbon 3 and the bond is single. So propane, pro for the number of carbon, pro, and the bond is single. So this is M. So propane. So the position of this chlorine 1, the position of this chlorine 2, 1 2. The number of chlorine di, therefore di, 1 2 di. This is chloro group. So this is chloro, 1 2 dichloro. The number of carbon pro, because the number of carbon 3 pro, and the bond between them single. So N, propane. And the next one, if we write in this way, CH3 CHClC. Okay, this is vicinal. We may call them ethylidene dichloride. Okay, or we may write in this way 1 2. The position of this chlorine 1, the position of this chlorine 1. So we may write in this way 1 1 dichloro and eth. So eth, the bond between them single. So ethane. So 1 1 dichloro. Okay, 1 1 dichloro, or we may call it ethylidene dichloride. This is vicinal dichloride. This is ethylidene dichloride. Okay. Now take more examples. I hope you understand. Very good. This is very easy. The organic is very easy. Really, it is very easy if you understand it, if you give your focus on it. CH2 double bond CH. There is a rumor that organic is not easy, organic is so hard. We cannot do organic. It is not. If you focus on it, if you practice on it, you may score, you may create your base. Organic is very interesting. 1 and 2. Okay. Okay. In the next video, I have discussed that this is ethene. If we remove one hydrogen from this group is called vinyl. If we attach here a chlorine, this is vinyl chloride. See this compound? Similar. So this is vinyl group and this is chlorine. So we call it chloride. So this is vinyl chloride. What is this? Vinyl chloride. This is phenyl chloride. Okay. Okay. Now take more examples. CH2 double bond. We also call it one chloro. The number of carbon 2 and the position of this double bond is 1. So we call it 1-chloroethene. Okay, or eth 1. If the bond is single, this is N. If the bond is double, this is in. If the bond is triple, this is IN. Okay. So the bond is double, so in, and the position of this double bond is 1, so 1 in. You may call ethene, it 1 in ethene. Oh, 1-chloroethene. Okay. Okay. Now we take another example. CH3, CH2. Okay. Write the name of this compound simply. 1, 2, 3. 1, 2, 3. So the compound is 1-chloro, 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 1-chloro. The position of this double bond is 2. So 1-chloro, 1-chloro, pro, 2 in, 1-chloro, pro, 2 in, or okay. But this is not. Why? Because the numbering is not correct. The preference, chlorine and double bond. The most preference, or we most prefer the double bond. Therefore, the correct numbering is 1, 2, 3. Okay. So the correct name is 3-CHLORO, 3-chloro, pro, 3-chloro-pro, 1 in, or propene. Prop 1 in and so on. Okay. Now take another examples. This is also the general name of this compound is aryl. Okay, so we may call it aryl chloride. The general name. Because why it is aryl compound? Let's see. CH2 double bond, CH bond, CH2 bond, Cl. Okay. The hybridization of this carbon is sp3. Why it is sp3? Because the sigma bond, 2 hydrogen means 2 sigma bond, and this is also sigma bond, this is also sigma bond. The number of sigma bond is 4. The number of sigma bond is 4. And we know if the number of sigma bond is 4, this carbon is sp3 hybridized. And the hybridization of this carbon, this is double bond. And we know where double bond is present, the hybridization of that compound is sp2. So the hybridization of this compound is sp2. And we know it if the chloride or if the chlorine is attached with the sp3 carbon, and the sp3 carbon is attached with the sp2 carbon, then this type of group is called aryl, and this is chloride, so this is aryl chloride. Okay, this is aryl chloride. Now take 4 examples. This is benzene CH2Cl. So this carbon is sp3 hybridized. Why this is sp3 hybridized? Because this bond is sigma bond. 2 hydrogen means 2 sigma bond, and 1 chlorine is also attached with this carbon with the sigma bond. So 1 sigma bond, 2, 3 sigma bond, and this is 1, 4 sigma bond. 4 sigma bond means sp3, and this carbon attached with this double bond factor. So this is also sp2 hybridized carbon. So chlorine is attached with the sp3 hybridized carbon, and this hybridized carbon is attached with the sp2 carbon. So we may call this benzyl. So this is benzyl compound, and we can call it benzyl chloride. Benzyl chloride. Okay. Okay. Now take 2 more examples. This is very easy. The carbon H, and we react with chlorine, and Cl is removed. We react with chlorine, and Cl is removed. We react with chlorine and photon also. The H is removed. We react with chlorine and okay, and we get this compound CCl4. CCl4. The number of chlorine is 4. So this is tetra, and this is chloride. So this compound is tetrachloride. What is this? Tetrachloride. Okay. Very easy. Okay. Similarly, if we write CH3Cl, this is monochloride, or you can call monochloromethane. Okay. If we write CHCl3, trichloride, you may call trichloromethane, or you may write 1,1,1 trichloromethane. Okay. This is the IUPAC nomenclature. Now we go to the physical properties of this chapter. Write the physical properties. Physical properties. Physical properties. Physical properties. Right. Nature. NATUR. Nature. Okay. Nature of C bond X. C bond X means this is CH3 1 2. Therefore this eth. The bond between them N. So this is ethane. We remove one hydrogen and we attach the chlorine. What is X? So this is C and this is X. This is C and X. The bond between them is called C bond X. The nature of C bond X. Let's see. If we write C bond X, we know X means chlorine, bromine, iodine. So nature of this X is negative. So we may write it delta negative, and the carbon obviously delta positive. Okay. Now, if we write CCl, if we write CF, we write CCl, CBr, Ci, and the given problem is rearrange or arrange the sequence on the basis of bond length. Bond length. So we know the group 17, fluorine, chlorine, bromine, iodine. fluorine, chlorine, bromine, iodine is arranged down the group of the periodic table. And we know if we go fluorine to iodine, the size increases. If the size increases, why the size increases? Because the radius increases. So size increases. Why size increases? Because radius increases. Why radius increases? Because number of cell increases. Why cell increases? Because number of electron. Okay. So down the group fluorine to iodine, size is increasing because radius is increasing, because cell is increasing, because number of electron is increasing. So we know the bond length is inversely proportional with the size. So the size of the fluorine is very small. Therefore, the bond length of the fluorine and fluorine's carbon-fluorine compound, the bond length of carbon-fluorine compound is high because the bond length of the fluorine is low. Because the size of the fluorine is low, bond length of the fluorine is high, so carbon-fluorine bond length is high. Okay, so we get this arrangement. Carbon fluorine bond length is the highest bond length of this arrangement, then carbon chlorine, then carbon bromine, and then carbon and iodine. Okay, clear? Down the group size increases because with the increases of radius, and the radius is increasing with the increases of cell, and cell is increasing with the increases of number of electron. Therefore, we get this arrangement: carbon fluorine, carbon chlorine, carbon bromine, carbon iodine. Now talk about bond length, bond dissociation energy. Bond dissociation energy. Bond dissociation energy means the bond we want to break it. For this reason, we need energies. So these energies to break this bond is called bond dissociation energy. So if the bond is small, okay, we need more energy to break it. If the bond length of the compound of the C bond X, if the bond length is more, we can break it easily. Just think about, if you have a long chalk and you want to break it, you break it easily. But you have a small chalk and you want to break it, you require more energy, or you cannot. So we call size is inversely proportional with the bond length, and bond length is also inversely proportional with the bond dissociation energy. The bond length is high, bond dissociation energy is low. So now CF, CCl, CBr, Cl. We know the bond length of this compound is high. Bond length of this compound is high. If the bond length of this compound is high, that means bond dissociation energy is low. So the bond length of this compound is very low. Therefore, bond dissociation energy is very high. So the arrangement is this. Easily we can see. Okay, this is a vital point. Now, last part of this chapter, of this topic, physical properties. And last topic on today's lecture. And I know you are eagerly waiting for the next video. And I promise you, I give the next video as soon as possible. Okay. So physical properties, the last part, electro dipole moment. The order of dipole moment. Order of dipole moment. Problem is same. CF, CCl, CBr, and Ci. The problem is we know we have a simple formula, that is mu, and mu equal to, we know, E and D. So it is E and D, E and D. What is E? E is denoted as the reference of electronegativity, and D is the distance. Therefore, mu, with the increasing of electronegativity, mu is increasing. With the increasing of distance, mu is increasing. There is a problem, because electronegativity of this compound is high, but the distance of this compound is low. Electronegativity of this compound is low, but the distance between carbon and iodine is very high. So what factor is going on? What is the dominating factor on this sequence? So if we arrange according to the electronegativity, we get CF, CCl, CBr, and Cl. This is the first problem. So if we arrange it, CF, CCl, CBr, Ci, it is not the right sequence, because the size of the fluorine is very low. Therefore, the surface of this fluorine is short. If the electron comes on this surface, the electron repulsion is occurred here. Okay. So there electronegativity is not working here. So the correct equation is CCl, then CF, then CBr, and then C. Sorry, this is not the sequence. So the original sequence is, this is solo, then this. Okay. There the factor is distance, because the distance of carbon, bromine, and carbon iodine, the distance of carbon iodine is high. Therefore, with the increasing of distance, mu is increasing, so the dipole moment of this compound is high. But here distance is not what. Okay, here electronegativity is what. Distance of this compound is low, but the electronegativity of this compound is high. Therefore, fluorine has high electronegativity. So electronegativity of this fluorine of this compound is high, so the dipole moment of the compound. So chlorine to fluorine, electronegativity is working, and bromine to iodine, distance is working. Okay, this is a vital question. चलो अच्छे से पढ़ते रहो, ख्याल रखो अपनी फैमिली की, और करते रहो, एंजॉय करते रहो. Thank you. Have a nice day.